saw in the demo how objects can be created. What you saw without realizing that you saw it also was objects going away. Objects have a lifetime, and when you declare an object like that, person P1, we say that it's allocated on the stack. We step over it in the debugger, and having stepped over it, we've allocated the memory, we've used the constructor to initialize the object, and the object's sitting there alive, but P2 is not yet. Then we go over the next line in the debugger, and now P2 is allocated and constructed. When those two objects, what we say, go out of scope, which means reaching a closed brace bracket in most cases, then the memory is freed, and the opposite of a constructor, known as a destructor, runs. Destructors don't have to be written. They don't have to do anything. In the case of person, there's no need to write a destructor to clean up at the end of the object's lifetime. There are some kinds of objects for which you do need to write a destructor. And in C++, we have this saying or this idiom, RAII, resource acquisition is initialization. And that's a way of thinking that says, if I have a resource that needs to be managed, let's say an open file or a database connection, or even something like the Windows cursor, in the constructor, I will acquire the resource. That is, I'll open the file, I'll open the database connection, I'll change the Windows cursor to a wait symbol, and I'll do the opposite and release the acquisition and clean up in the destructor. So I'll close the file in the destructor, I'll close the database connection in the destructor, I'll put the cursor back to where it should be in the destructor. And this pairing up, that the resources are acquired in the constructor and released in the destructor, means that developers really don't need to think about it. They create an object on the stack, constructor goes off, stuff gets acquired. Later, it goes out of scope, destructor goes off, stuff gets released. And the old school days, if you're a person who ever worked in C, where you have to say, now remember to close things when you're done with them. Remember to open things before you use them. This approach says, look, relax. When you construct the object, we will acquire whatever needs to be acquired in order for you to use the object. We'll open the file, or we'll open the connection, or whatever. And when you're done with it, when it goes out of scope, it will clean up itself. You may have heard that in C++, you have all this complicated, difficult memory management, and you have to delete things and all this. That's just not true. There are some ways of programming in C++ that put tremendous burden on the developers to just remember a million things. But the RAII approach, which says when you make an object, the constructor gives it to you ready to use. Whatever needs to be opened is opened. Whatever needs to be allocated is allocated. And the destructor will close it up and clean it up for you. That way, when people, especially when you get to use objects from a library, they just work. They do what they need to do. I'm going to stay away from opening files, making connections to databases, changing Windows cursors, because they're reasonably difficult tasks to do. But I am going to show you how this works. I'm going to come back into Visual C++ Express and come into the person class. And I'm going to add a line to the constructor that just prints out a statement that we're in the constructor. That'll help to be able to track when the constructor runs. And after we add a destructor, we'll also be able to check when the destructor runs. I'd like to print something out on the screen, so that means I need to include Iostream. Then I can just come in here and say, in the standard library, I'd like to use cout, and I'll send it constructing. And just so I can tell them apart, I'll send the first name and a space and the last name, and then an end line character. Now, every time we construct something, there'll be output written out that we can take a look at. I'm now going to add a destructor to this class. It doesn't really have any genuine work to do. We don't allocate or acquire any resources when we're initializing a person, so we don't need to clean any up. But I'm just going to add one so that we can have an output statement. And the rules for a destructor is that the name is this tilde followed by the name of the class, and it doesn't take any parameters. And then in here, I'm going to implement the destructor. When writing the constructor, we have to start with saying the name of the class, and then the name here of the destructor, and it doesn't take any arguments. And it has an open and a close. I'm just going to copy this line and now we're going to print out when the destructor goes off. I could just run this code as is. I'm going to make one small change. I mentioned that scope ends when control reaches a brace bracket. You can have a brace bracket for whatever reason you want. You might have them as part of some ifs and loops and things we haven't covered yet, but you can also just randomly have them. And what happens when I do this is, as we go through, first P1 will be constructed, then P2 will be constructed, then when we hit this close brace, P2 will go out of scope and be cleaned up, and the destructor will go off. Then we'll return from the function, and that will clean up P1. P1 will get destructed. Let me prove this to you. I don't need to do this under the debugger. I'll just use Control F5. Let it build. First, we constructed P1, which is me, then P2, which is someone else. Then, because we reached that close brace, we destructed P2, and finally destructed P1. Understanding the scope of objects that you allocate is important to know. The constructor goes off when control reaches that line. The destructor goes off when the object goes out of scope. I didn't need to keep track of these person objects myself and clean them up. Destructors went off simply because control reached this close brace, and that took the object out of scope. Important thing to understand that much of this is done for you automatically, and it's an important part of thinking like a C++ developer. I want you to be able to read and understand C++ code that you come across and C++ code that I show you. And in order to do that, I really want to minimize the times when I say, don't worry about this little magic invocation, we'll cover it later. And when I have to do that, I want to come and close that loop up again as soon as I can. A couple things, therefore, that I want to talk about now, because I think you're going to be able to understand the code I show you better if you've seen these things. First, I want to mention struct. A struct is a lot like a class. It's a user-defined type. It's often used for what we call plain old data or POD classes. They don't really have any business logic. Take a point, for example. It has an X and a Y. It doesn't have a method to validate it and make sure that it's a legitimate point, or to put it in the database, or to update it for a new fiscal year. It's just an X and a Y. Structs, however, can have everything that classes can have. They can have functions in them, including a constructor and a destructor. They only have one difference, literally one difference. I mentioned that if you don't say public versus private in a class, the default is private. In a struct, the default is public. That's the only difference. And you should never use the default anyway. You should always say the following stuff is private, the following stuff is public. And then that turns into there being no difference whatsoever between a struct and a class. As a matter of practice, most developers like to use structs for POD classes and classes for, full-on classes, but it could go either way. I've shown you how to write classes. I should show you at least the syntax for inheritance. Some of the significance and importance of inheritance will really only come into play as we move into doing more with our classes, but I'll show you how inheritance works to get you started for that. And I wanted to talk about namespaces. We've been using the std namespace and saying std : string to say this is a standard class from the standard library. A little bit more about namespaces and a little less typing, just so that your code will be a little more the way everyone else's code is. And then enum, which is a concept in a lot of languages, just a way to give names to constants. The C++ enum is a little bit different from some other languages enum, so I want you to see it and know how it works.